welcome to another episode of Ask Jerry and Ray Anything About IBM Z. Today our question is, what is IEBCOPY? And to
Thank you,
answer that
Ray.
question,
Let's jump into this. So we're going to cover some specific information about IB copy in this session, and what we'll cover is our agenda. So you got to advance the slide.
oh yeah, that's right, I got those. I keep forgetting that's my responsibility.
All right. So first we'll look at what is IB copy and what does it matter. Then we'll look at PDS versus PDSE. These are the data sets that IB copy works with. It also can work with sequential data sets if it's unloading or loading one of the two PDS or PDSEs. Then we'll look at the basic JCL structure for running IB copy. So, you just got your fundamental JCL. Of course, we're not going to stick with the fundamentals, but we'll show you that. Then we show you some more examples and how you can actually code things. Then we'll look at copy, unload, and load with JCL examples. Then we'll select, exclude, and replace members. Then we'll compress in place the entire PDS. And then finally, we'll take a look at return codes and troubleshooting tips. So let's jump into this. So what is IB copy? Well, it's a IBM system utility. It copies, merges, compresses, and reorganizes partition data sets. So that's the end of my reading for you. And basically, it can work with PDSs, which is the original data set. They have it's a single data set you can reference by name, and then you can specify the members in that data set. I think we've mentioned them before, but we're going to really dig into them in this session. Now, that's PDSs, and they were the only thing that existed for a very long time. And then IBM fancied things up, and they came up with PDSEs or PDS extended. So IB copy works with both of them and does all of its processing against either one of them. If it's a PDSE, it knows what to do. If it's a straight up PDS, it knows what to do. It ships with ZOS, some part of the operating system, and it says it works exclusively with partition data sets, whether they're PDSs or PDSEs, and it's a batch program. So that's what IB copy is. And why would one want to use IB copy? Let's take a look at that.
That's a good question. So why would you want to use IEBCOPY? Well, the simple answer is you want to copy data. You can copy data from a PDS to another PDS. You can copy it or unload it, as it's called, from a PDS to a sequential file. This makes it great for trying to transport it somewhere. You can copy things between, you can restore them from a flat file that's been unloaded. You can load it back into another PDS. This load and unload also helps you transfer items between PDSs and PDSEs. Copying directly from one to the other isn't quite so easy. And so IEBCOPY helps you do that. It's just a little roundabout that you have to do it. So that's a lot of the reasons why you would want to use it, or how you would use it. And so, again, talking about PDSs versus PDSEs, as Jerry said, PDS was the original partition data set. That was how things were originally set up. And you could think of it as a directory and members, but it's still a data set and members. PDSEs, similar thing, just a little bit more advanced. In a PDS, you explicitly have to tell it how many directory blocks there are, and if you run out of directory blocks, that's a bad thing. You can't make any more members in the PDS. PDSEs no longer have the requirement for directory blocks. It keeps track of all that stuff automatically. PDSs have issues with fragmentation, where if you start deleting members, you get little gaps in the PDS, and then it only puts new members at the bottom. And so all that unused space you have at the top, from where you've deleted members before, it doesn't get reused unless, as Jerry said, you compress it. And so compress in place is another function of IEBCOPY. Yeah, so those are the primary differences between PDS and PDSEs. You do have to allocate them slightly differently, but we'll get into that later. So the roadmap here we have with JCL Basics, how to build a job for an IEBCOPY. I guess I'm still going then.
Well, I can pick it up.
Okay.
So this is your basic fundamental JCL. Of course, you have the execute, you have the job exec, and the DD statement. We've talked about that ad nauseum. But in this case, you have two specific DD statements that are referenced. If you don't specify anything else, if you specify sysut1, that's going to be your input. Sysut2 is going to be the output. So in this case, we're copying from source.pds to target.pds. Sysprint is where your output goes. And in this instance, we don't need to tell IEBCOPY anything. We want to copy everything from source to target. And so sysint is dummy. So there's no control statements needed. So we actually get into a little more gory details. It says copy is the bread and butter of IEBCOPY. And this is what IEBCOPY is for, to move things between PDSs. You can preserve attributes, aliases, and statistics. Now, it didn't used to preserve aliases. If you just copied a member, if you copied an alias member, it would make that into its own member of the PDS. And that caused all kinds of issues. So we probably still have some JCL that has comments that you have to run this by IEBCOPY, otherwise you'll mess up the aliases. That's no longer true. They finally have fixed that, both for PDSs and, of course, PDSEs. So your full library copy copies everything from one PDS to another. You can merge members from several input PDSs into one output. Like I said, it preserves the attributes. And if you go back,
Ah. Well, you were talking about merging, so I got a little excited.
he's anxious. So we have if you have an ISPF data set, you can have member statistics. Well, those are stored in the directory of a PDS. And so those are preserved, all your aliases, any user data. You have the option of adding information to the directory as well. So all of that's retained with IEBCOPY. And it handles duplicates. You can tell it, look, if there's already a member by this name there, I want to replace it. If you don't tell it, the default is, hey, it's going to put out a message, hey, I didn't copy this one over because it was already one by that name in the target data set. All right, so we can move on to our JCL example. And in this case, we've got 3 data sets. We've got 2 input data sets and 1 output data set. And what we specify in this example is that we want to copy every member from dev.source.loadlive and every member from dev.source2.loadlive into prod.target.loadlive. So it'll show you, I'm copying from the first data set. It'll show you all the members it copied. Then it'll say, I'm copying from the second data set. It'll show you all the members that it copied. So life is good.
Mm-hmm.
All right. So I'm going to turn it over to you, Ray.
All right. So yeah, the unload, as I alluded to before, allows you to take members from a PDS and unload it into a sequential file. That allows you to create backups of a member before you make big changes to it without having to copy the entire PDS to a backup member. Um, and then it also allows you to transport it from one location to another because, again, it's now a sequential data set. It's a lot easier to move around. Uh, and again, its primary function is backing up your data and at a very granular level. You don't want to use this for like your system backups um, because that would be uh, it'd be excessive. You'd have to have giant jobs to do that. Uh, but in order to take the flat file and put it back in, as I said before, you have to use the load function, which is opposite side of that coin. So here's an example of the unload function. It shows you that uh, your sysin now has keywords in there. You're using the unload function as opposed to the copy function. You have your input member, which at this point we're still actually pointing it to the whole load lib. You can also point it at individual members. And then because we're creating a sequential file, we have to put in the JCL statements for how to create this file. So you've got your information here. As your new catalog delete tells you what happens, you know, as the first step of the job. Is it a new data set? Is it, something that already exists? What happens when it finishes successfully? We want it to be cataloged. We don't just want it to be out on DASD uncatalogued. And then what happens when it fails? Well, we delete the data set because we don't want the potential for duplicate names. There are defaults for each of these three dispositions. Can't remember if we talked about that in our other JCL primer, Jerry.
I think we did, but that's been a
Okay.
long time ago. So
Yeah. Yeah, you can check that out and see if it's got it in there. If not, let us know, and we'd be happy to make some more videos just talking about defaults and basics. So
now
then,
I think in the DD statement that has to actually be a PDS. If you want specific members, you've got to specify that with the select statement in the sysin.
good call.
Uh, Yeah, because otherwise you got to when you give it a member, you got a sequential data set, and IEBCOPY will probably say bad things to you if you do that. So.
Yeah, I actually haven't tried doing this myself before, so assumptions will get you into bad places sometimes.
But hey, we're here to help each other out. So
Yep. So then, like I said, the flip side of this is your load. You take that data set you just created uh, with the member or members that are in there, and then you want to load them over into this new load lib that we're creating, the restore.target.load lib. And so we've also got information here on how to create a new PDS. The important thing to look at here, though, is on the space statement, you have three numbers now. Instead of just your primary and secondary allocation numbers, you now have a directory block count. And so this helps the PDS allocate space up at the front for its directory information. As Jerry said, it keeps track of the members, the ISPF stats, and all that information. Now, I will say, Jerry, the one thing I don't think I've ever really figured out, how do you determine how many directory blocks a PDS is supposed to have? Is there a generic one directory block takes care of X number of members?
well, it depends. Now, if you have ISPF statistics, it's going to take up more space.
Okay.
If you have just your basic directory entry, it's going to take up a certain space. There's a formula out there that you can calculate. I just allocate a lot. That's my
Yeah.
answer. I allocate a
Okay.
lot of directory blocks because I don't want to have to deal with, oh, oops, I ran out of directory blocks. I've got to do all this fancy dancing. Now,
Okay.
we snuck one in on you. This one says DSN type equals library. that makes it a
Ah,
PDSE. But we,
I didn't
we
catch
just
that.
wanted to slide that through there, so you had to be paying attention, so that you knew that happened.
Actually, wouldn't this JCL allocation fail because a PDSE can't have directory blocks?
Actually, no,
Really?
because I've run into problems where I didn't give it. If I didn't give it because I said, "Oh, this is a PDSE, I won't give it directory blocks." It cussed me. So,
Really? Okay.
yeah.
All right. Learning new things every day. Well, so that's pretty much it for the load and unload. So now we're getting into the advanced options. This lets you do other things like select certain members. As Jerry said, what happens when the member that you're copying to already exists, uh, and other fun functions. So I'll let you take it back, Jerry.
All right. So, select says, "I want these members." And you give it the data set, the DD statement, and the member name that you want, and it says, okay, that's great. You can also say, and I'll save that for later. So in this case, we say we want members A, we want MEMBA, MEMBB, and MEMBC. We want those three members that are in NDD1 copied in the out DD. Now, if they're already in out DD, it's going to give us a message saying, hey, it's already there. I can't copy it because we didn't tell it, what to do if it's the member's already in place. On the other hand, we say, okay, I want to go to NDD2 and I want to copy everything except old PGM and test PGM. So it'll copy everything except those two. Any duplicate members, it'll say I can't because they're already there, and you've got your data set copied the way that you want it. Have to check the sysprint to make sure it did what you want. I think if everything's fine, it gives you a 0. If you run into something like duplicate members, it gives you a 4. So it says, hey, I copied everything I could, but you might want to check to make sure that the results are what you expect it to have.
Okay.
So we've got select and exclude. Then we've got the replace option. So you've said, okay, I don't care if it's already there. If it's already there, replace it or overwrite it. So you give it, and this is real, this gives me the blues every time I try to do it originally. If I can't find something to copy, some JCL to copy, then I'm left on my own. Of course, now this is back in the olden days before AI. With AI, I can always ask it, hey, how do I do a replace an IB copy? And it'll give me something, and hopefully it'll work. If it doesn't work, it'll fail, and then we've got another problem. But you can say, okay, I want to copy, in this case, my prog, and I want to replace it. So if it's already in out DD, then fine, that's good. I want to replace it. If it's not, it just goes ahead and copies it like it normally would, and everything is fine. You can also rename that member. You can say, I want my prog, but then in the middle, so right in the example, we have two commas together. That means I'm going to keep the original name. If we had something in between those commas, then that would be the new name of the member. And then it would fall into the category of, okay, let me make sure that there's not a member by that name. But since we said replace, it says, okay, we're good. And it'll proceed and life is good. And as it says, the default, the member is skipped if it already exists in the target. So we talked just briefly about return codes. So of course, we'll have to go into much more gory detail on the next slide.
Oh,
Oh,
yeah.
I'm
Next
sorry.
we got
I
compress. Yeah.
I I got excited.
Yeah.
I forgot about compress in place. Now, we talked about when you create a new member, I mean, when you replace a member in a PDS, let's say you're in ISPF edit, you make some changes and you save it. Well, what it does is it takes that updated member, puts it at the end of the data set, and leaves that original space unused. And eventually, you can get to the point where you don't have enough room to put another member in there. And what you have to do at that point is compress it. Well, IEBCOPY takes care of that compression. And the trick is OutDD and NDD point to the same data set name. And when it does that, it says, okay, we're good. And it'll do the compression. Um, One of the rules a long time ago, it had to be disk equals old. Because if you tried to compress a data set and somebody had it allocated, it would really mess things up. So you always had to say disk equals old, make sure nobody had it allocated. Now,
Hmm.
over the course of time, IBM has improved the code, and if disk equals, you can specify disk equals share, and it will say, "Oh, okay, fine. I'm going to make sure that nobody tries to update this while I'm running. They can have it allocated, but if they don't try, as long as they don't try to update it, we're fine. If they try to update it, we'll tell them, look, you can't update it because somebody's compressing it, or depending upon how what the timing is, it may tell you, look, you can't copy this because somebody's trying to change it. So that disk equals old is required to get exclusive access. And of course, it won't work with a PDSE. Why? Because PDSE doesn't have the problems of chunks of space being left in the data set. When you delete a member out of a PDSE or add a update one, it says fine. I know what to do. Oh yeah, I'll mark this as unused data, and sometime or another it comes back and free up all that unused space, so that you don't run out of space because of replacing members.
Now,
So Ray's going to tell us about common return codes.
quick little ISPF tip. If you're in a data set and it tells you you've run out of space and it's a PDS, you can actually just back out, and at the line command next to the data set name, just type the letter Z, uh, and it'll compress right then and there for you. I'm guessing it just invokes IEBCOPY under the covers,
Yes.
but yeah, that's a fun little trick. So you don't have to go back and find, a compress JCL member somewhere. But as Jerry said, the next topic is return codes. And so return code 0, hunky dory, everything's good. This is what we like to see. Return code 4 means there's some warnings. Probably, usually, it's a member in the target data set already existed, and so it didn't copy something from the source data set. Then return code 8, it's an error. That's not good. Um, the error message will be in your sysprint output, so whenever you run into problems, sysprint's the first place you look. Uh, it'll have a message number, message description. If it's still kind of uncertain what it means, you can always just look it up online. I always type in IBM, then the message number, and see, what I can get. And next, return code's 12. Seems we like to go up by fours. Return code 12, well, that's even worse. Means there was a data set or an I/O problem. At that point, it's probably some kind of a serialization issue or some other not major, but big problem with one of the two data sets, either source or target. Uh, as always, check the sysprint, look up the message, fix it, rerun the job, or ask somebody for help if it's still a little too cryptic. Finally, you got 16. This is your severe, very bad things have happened message. And so that you don't typically see 16s, but when you do, it's definitely one that, requires a little more investigation. Um, I don't know if I've ever seen a 16 on an IEB copy,
I
but
have.
oh, okay. What kind of an error
And
was it?
I left out the sysprint DD statement.
Oh,
So it couldn't even give me any information at all. So it said, okay, we're gonna shut you down quick.
kind of surprised that wasn't like a JCL error. Uh,
Well, JCL
Yeah,
doesn't know what the program needs.
yeah,
That's why you can get away with allocating things with IEFBR 14.
yeah,
IEFBR
true.
14 doesn't have any DD statements, so
Yeah,
it's not trying to open anything. So, but yeah, I did that once and I scratched my head and I said, oh, kind of neat. And I think you get a message from the system that the sysprint
yeah.
DD statement is missing. And then you
Okay,
get a return code 16 because it can't tell you anything because there's no sysprint DD statement.
yeah. I think that's why I thought it was a JCL error, is because it does show up in the JCL as, missing DD statement.
Right.
Right. And then some tips and best practices. Uh, for one tip, always make a backup. Uh, whenever you're going to be doing something that very, majorly changes some of your data, you always want to back up just in case. Uh, this is also great if you're about to upgrade a product. You can make a copy of the dataset load lib. And so as you upgrade the product, if something happens and you're forced to back out, it's a lot easier to you know, either load from your backup or uh, delete it and again load, but reallocate the data set than trying to find an HSM backup and hope it's the right version, has all the latest changes. This is your best way to make sure things can back out if needed. Uh, and then, as I mentioned multiple times, check your sysprint for any kind of error statement. If it's in there, you know, usually it's pretty good about telling you what the problem was. That's one of the nice things about the mainframe. Error messages are usually pretty descriptive and tell you almost exactly what you need to fix. If not, there's plenty of message guidelines or message guides online. Uh, Other people have had the same issues, so they show up on forums, uh, things like that. And yeah, any other tips besides what we have on the screen here, Jerry?
Well, I would say whenever I get an error message, I always give it to AI. It tells me what the message means and how to fix it. So that's my go-to, on those rare occasions when I have an error.
Well, that's kind of the funny thing. I generally would rather look it up online. To each their own. All right. So I think that about covers us for IEB copy. Uh, had the fundamentals and some JCL examples. So go forth and do good.
All right. So um, I was noticing that we mentioned ISPF several times in our discussion. And it's possible that you use ISPF, but maybe not to its fullest usage. So I think we're going to have a multi-part series on ISPF. We're going to go from your basics and add up a little, make it a little fancier, and then you're going to get to the sneaky and devious things that I do. So we'll have fun.
Yeah.
So don't forget to subscribe, hit that like button, and we'll see you again next time.
Thanks for joining us.